Hello, everybody. We're just opened up the session now, so we'll just give it a minute or two to get our attendees populated. So just hang tight and we'll get started here momentarily. All right. Okay, it looks like our attendees have started populating in, so we will get this show kicked off here. I'm Cody Cochran with MBSI WAV. Thank you all for joining us here, their first webinar of 2021. So MBSI WAV, we're very excited to introduce the CI platform, their complete microwave solution, to the Canadian market in a little more of a formal way. It might be a new name to some of our attendees, but they have been around for many years and they've deployed networks in over 100 countries in the world. So we're very excited to introduce this platform, or if you're new to it, or just getting you some general updates if you are familiar with it. Just some general housekeeping here before we kick off. This webinar will be recorded and uploaded to our social media outlets shortly after we are done here today. So if you happen to get distracted or have to step away, or if you want to share with a colleague or somebody in the industry, feel free. You can check out our YouTube, LinkedIn, Facebook shortly after we're done here today, and you will find a recording of this webinar. As we move along, if you have any questions or comments, please feel free to drop them in the chat window as we move along. We will do our best to maybe field them as we go, but most likely we will be addressing them at the end of the webinar. If we happen to run out of time, we'll make sure we personally reach out and address any questions that might be outstanding. If that chat window does not automatically open for you, there is an icon at the bottom of the window to open it up. So that's where you can find that. Also, please do pay attention during the webinar. We will be asking a question related to the content at the end of the session. The first person to answer correctly will win a $100 Amazon gift card. Please do keep in mind, to be eligible for the giveaway, you must be a resident of Canada. So we do welcome folks from outside of Canada, obviously, to join us here, but to be eligible for the giveaway, you got to be in the Great White North here. So just before we pass things along, here at MBSI WAV, we're extremely excited to see Canada's licensing cost structure most likely to change in the spring. Again, fingers crossed, knock on wood, it's looking good, but as far as I know, it's not 100% confirmed yet. Pairing that along with some of the new multi-point technologies that we're seeing, in the 60 gigahertz space and some in the 5 gigahertz that can deliver these huge packages, this huge capacity to your end customer and sites. It's really going to, expand what we're able to do out there in the rural markets. So do keep in mind, MBSI WAV, we can help with planning, network design, post and pre-sale support on every piece of a wireless network, including CI's microwave solutions, which we're about to see. So presenting today on behalf of CI is Joseph Schrammel. Joseph is the VP of Sales and Marketing with CI. So with that, Joe, I'm going to pass it over to you and let you get things going.
Great. Thank you very much, Cody. And welcome, everyone. Thank you very much for taking time out of your day to join us on the webinar. Joe Schrammel here with CI Microelectronica. As Cody mentioned, I'm the VP of Sales and Marketing, and specifically Channel Sales and Marketing here for CI North America. And wanted to again say thank you for the time. You guys can see my screen okay? You can hear me okay?
Absolutely.
Yep. All right, good deal. Well, let me take a few minutes to what the purpose of the webinar here really is, just to kind of introduce you to CI Microelectronica, our company. Some of you may be familiar with CI. We're a fairly new entity here in North America, been around a long time, however. Wanted to also take the time on the webinar to introduce the microwave products. So I'm not going to really talk about applications. Many of you on the call already know the applications that you may be using these products for. Whether it's mobile backhaul, private enterprise, internet service provider, maybe in the utility market space, local, state, local, government or provincial and local government up north, so rather than talk about applications, we really wanted to focus on the company and the product and introduce you to us here. So CI Microelectronica, actually founded in 1952, been around going on 69 years now, been doing microwave radio for a very long time. You kind of see the timeline here on the slide. Privately held, Eduardo Machete founded the company. His three sons now run the business. And continue to evolve the technology and invest in the technology as microwave radio has certainly evolved over the years. I've been actually doing microwave radio since 1985, so I've been part of this evolution for quite a long time. CI Microelectronica has 2,000 employees, or just over 2,000 employees worldwide. Here in North America, we are one of 26 subsidiaries. As mentioned, been around since 52. We own our own factory, and I'll kind of dive into that on the next slide. So we build on average between 8,000 and 12,000 radios a month at our factory in Italy. As Cody mentioned in the introduction here, we're in over 100 countries. We also have a services group where we do a lot of services, mostly in Europe and some in the APAC region. Where we have revenues are typically split 70-30 with hardware services there. As we evolved the company, we acquired the optical group from Alcatel-Lucent back in 2014 and launched the SM Optics brand. So doing CWDM, DWM optical terminals. Those are right now focused on Europe. We haven't brought those into North America, but just kind of gives you an idea of the breadth of the company and the how the company's been structured over the years here. So in regards to operations, we actually do our own production. We have a full factory in Milan, Italy. We've got probably about 30 to 35% of our staff are design engineers. All these the radios are built from scratch. There we do we have our own surface mounts, own wire bonding machines there, clean rooms, etc. And it really gives us a stronger level of quality, a stronger level of control over the product. We're able to kind of control our own destiny, if you will. It's a very, we don't really rely on contract manufacturers to do stuff for us here. Typically, we install about 20,000 links per year in Europe. Certainly, that's on the services side. And then the bottom bullet point here is we've been well into the carriers in Europe and the Middle East, Latin America with the tier 1 pedigree. So you'll see on the next slide here, let me just kind of pull that up here. Oh, carrier grade solutions. So all of our radios, we do test them over extreme temperatures, make sure that they operate in these harsh environments that the mobile operators are using. We typically spec them from -33C to +55C. But you can kind of see on the graph here, what we do is we actually do a 24-hour test with the radios. We actually bring them down cold, we turn them off, we cold start them, which is the kind of the worst environment to test these radios in, bring them back up to room temperature, then ramp them hot and check performance during the temperature cycle there. All hardened carrier grade construction. No, we don't use plastic, metallized plastic or anything like that. So when you lift a CI radio, you'll see it's a very solid design there. And there's some of the global references, customers that we've worked throughout the world with here. So MBSI certainly in Canada, WAVE here in North America, Frontier, Sprint now owned by T-Mobile, Telefonica down in Latin America, over in Europe, Middle East Africa region. Sorry, Vodafone, got everywhere or everything everywhere. MBNL, Etisalat, SFR in France, MTS in Russia, and then of course in the APAC region, some very well-known names. So been around a long time, a lot of experience with microwave radio, specifically with the carriers, mobile operators. You know, we started SIAE here in North America back in 2013. I joined here in 2015 and expanded the business, and really looking forward to working with our friends up in Canada and expanding into the Canadian market here. Some of the stuff that we do for the 5G networks. Won't go into all the details on the slide here, but we are working with a number of mobile operators worldwide to implement our products for their 5G networks, including SDN, where we are working with, for example, Vodafone and Telefonica, and being able to bring these products into these next gen 5G networks here. Our headquarters for the U.S. and Canadian operations are in Dallas, Texas, or right outside of Dallas, Texas. It's very, very central to the U.S. Also, a very good region in the country where there's a lot of high tech. We can draw on resources from the industry, different high tech industries there. We've got a number of support folks in the Dallas office. We've got regional sales guys, Joel Corumbus on the West Coast, Shimon Ben Sadiq on the East Coast. You can kind of see in Canada where their territories lie. Randy Montoya also does some strategic accounts. Chad Franz down in the southern part of the U.S. It's kind of how the group is structured. We've got a number of support folks in Dallas, also on the pre-sales and post-sales side. So anything that needs support, you're actually working with a group here in North America, as opposed to having to work with a group in Italy, some 6 to 9 time zones away, depending on which part of the country you're in. Okay, and as was mentioned, here's our facility in Dallas, Texas. We're actually on the DFW airport property, so getting product in from Italy is fairly easy and quick. We've actually just moved into this at the end of 2019. We expanded the warehouse. Business is growing and needed a bigger space. One of the nice things about this facility here is it's not just our warehouse, but this is where we do all our support from. So we have in our Dallas office, we've also got a lab where we rack everything that we sell here in North America, whether it's ALFOplus2, ADHDX, a split mount, etc. All in the lab, all accessible by our support guys who are working with you. You got a configuration question, we can actually replicate your setup there in the lab and help walk you through it. We do some training out of there. We actually have a full classroom. Once a quarter, we'll bring people into the classroom. We are actually doing virtual training right now because of the COVID pandemic, but we certainly have a hands-on training there. And we do all our RMA support out of Dallas too. But one of the big things about the Dallas warehouse is that we augment the inventory that MBSI has on the shelf. So if by chance they don't have it on the shelf there at MBSI, we've got it on the shelf in Dallas, and we can facilitate fairly quick shipments out of the Dallas office there on behalf of MBSI. Okay. So as mentioned, we just focus really on licensed microwave. So you won't find any multi-point stuff or 5.8 stuff or 2.4, 60 gig stuff's not in the catalog. We do have one unlicensed radio. We'll talk about that on the subsequent slides. But really, we have licensed wireless solutions really for any distance, capacity, upgrade, and direction. We've got point-to-point links. We've got nodal solutions, things like that. We'll really focus on the microwave on this presentation. While we do sell E-band radios, and the E-band specs have been released by Industry Canada some time ago. We understand the license structure there is kind of prohibitive to have multi-gig links, multi-gigabit links. Hopefully that will change in April, as Cody mentioned, with the new fee structure. We're crossing our fingers that changes. As you probably know, it's quite expensive to get some licenses there. Okay. So our product family really here for North America, we have radios that operate from say 100 megabits per second all the way up to 10 gigabits per second. And when we talk about the throughput here, we're always talking in terms of full duplex throughput. So we're not doing anything with aggregate or anything like that you might find in the unlicensed band. This is true go and return throughput here. So our ALFOplus radio, single all outdoor, we'll talk a little bit more about that. Good up to about between 100 and 500 megabits per second. Our AGS-20 system is a split mount solution, so you're a typical indoor-outdoor architecture. That's also nodals. We can also use that in a nodal solution. But the crux of the presentation is really going to focus on the ALFOplus2XG. This is our 6 to 38 gigahertz licensed microwave solution. I'll touch on the E-band stuff toward the end there. And certainly in the chat window, if you've got questions about, want more information maybe on some of the products that I did not cover on the webinar, certainly drop us a chat and we can follow up with you on some more with those products here. So let me talk about the ALFOplus2XG. This is really an RF multi-core solution. That's our marketing speak for dual carrier radio. So with this, it's you've maybe seen other dual carrier radios on the market. There's other vendors that make them. With the SIAE solution, we'll kind of dive into what makes this unique. Really, with the ALFOplus2XG, we contain essentially 2 radios in a single box. There's nothing else that we need to add to make up the system other than the antenna and some power. A single IP address for both radios. So from a management perspective, it simplifies your management. And you can see in the RF configuration can do a number of configurations: co-channel adjacent polarity, CCAP, adjacent channel, adjacent polarity, or it could be first adjacent channel or even say second or third adjacent channel, depending on the radio. And then in the third scenario here, you've got adjacent channel copolarity operation, where you've got 2 carriers on the same polarity, could be adjacent channels, or they could be second adjacent channel, et cetera, et cetera. A fully integrated branching system, we'll go ahead and dive into that in a subsequent slide too. So with our ALFOplus2XG, this radio is capable of up to 2 gigabits per second. It's actually over 2 gigabits per second in certain ETSI flavors, depending on the frequency band, modulation, and channel bandwidth. As mentioned, it's a dual carrier in a single outdoor solution. And the radios here, they actually have, we'll talk about this on a subsequent slide here, independent modem and RF sections here. We have a lot of our own in-house technology that we've developed over the years that we provide in our own SIP, system and package. And as I mentioned earlier, licensed bands from 6 to 38 gigahertz. This radio here is unique in that it was the first radio on the market that operated at 4096 QAM. So we actually released this in early 2016, while others were still working at 1024 or 2048 QAM. This came out of the gate at the 4096 QAM. Not a roadmap update or anything like that. Our engineers took the time to make sure it worked before we released it. Here in North America, it has the capability of doing up to 80 megahertz wide channels. Some of the ETSI flavors of the radio will do up to 112 meg wide channels. And the radio does have ACM with it. We'll talk about that in a subsequent slide. XPIC, cross-pole interference cancellation. One of the nice things about this radio is that you enable the second carrier with a license key, and the XPIC comes with it. So it's not a separate software license that you have to enable to just get the XPIC functionality. 4 Ethernet ports, there's a 10 gig port and 3 1 gig ports on it. And then the total switching fabric on this radio with the 4 ports is 46 gig wire speed. So it's nice because it's the packet performance doesn't suffer because of the internal fabric, switch fabric, and we can maintain very high packet rates, very low latency across the microwave link here. We'll talk about the PoE on a separate slide here. So some of the software features, it does layer 1 aggregation, so we can feed either 1 or 2 cables into the radio, aggregate traffic that way with the ALFOplus2XG. The nice thing is you can feed a single 10 gig fiber into the radio, and that the radio doesn't need the aggregation at that point. SMOS based SIAE microelectronic operating system. For those of you who may be familiar with Cisco iOS, you can also manage the radio through CLI, and the CLI looks very Cisco-like. And we've done a lot of work with Cisco in the past to integrate our radios with some of their cell site routers. So therefore you'll see there's a lot of commonality. There's a lot of IT folks that just like using the CLI, and very simple to go in and configure the radio with the CLI there. So signal network element management, like we talked about. Also, features in the radio can be enabled multi-layer header compression. So if you get a lot of small packets, maybe voice over IP packets, you don't need to. You can do packet compression and improve the packet performance of the radio. Some of the carrier grade features for those mobile operators, SINCE and 1588 V2 support, including a transparent boundary clock. It's an MEF certified carrier Ethernet platform. We also do some OAM management, hierarchical QoS. It's got the ability to do AES encryption, either 128 or 256 AES. So here's kind of a block diagram of the ALFOplus2 radio. The nice thing about this radio here is that it has, I mentioned earlier, independent modems and RF. So what's really interesting about that, we have customers here in the US where, you know, the FCC might give them an 80 megahertz horizontal channel and say a 40 megahertz vertical channel. Well, we can do that. We can also do things like maybe the 80 megahertz channel can be 4096 QAM, and the 40 megahertz channel can be 256 QAM, and provide a higher level of link availability with the lower modulation. So independent modems and RFs in the radio, separate power amplifiers with some dual carrier radios on the market. When you enable that second carrier, the power drops by 6 dB because they share a common PA. Not so with the ALFOplus2 radio. You can go ahead and plan your links at the max power for both carriers, and the radio will support that. Okay, for those radio guys out there, or gals, if you've never seen a picture of a 4096 QAM constellation, this is what it looks like. Very compact, tight IQ pattern, and as you can imagine, the RF has to be really clean in order to be able to decipher the data coming from the other end. So your intersymbol interference is not affected by that. So again, this is first on the market. Again, been building this since 2016, so going on 5 years now. So the design is tried and true. Been producing thousands of these radios out of our factory in Italy. As you can also see on the slide here, 4096 QAM with ACM all the way down to 4 QAM. So in the event that you've got some path anomaly, whether it's a rain fade, something like that, we can adapt down to a lower modulation and keep the high priority traffic going over the link during those anomalies, and then certainly ratchet it back up to 4096 QAM during clear sky conditions here. And for For those of you who may have some older, I say older, maybe 10, 15-year older systems on the network looking to upgrade, you ask yourself, what does 4096 QAM buy me over, say, a 256 QAM system? That buys you somewhere between 40 and 45% throughput increase when looking at the 4096 QAM radios here. Just won't go into details on the chart here, but this is the simple chart here showing the relationship between throughput, bandwidth, and modulation for North American customers. 80 megahertz wide is as wide as we can go. Here in the US, it's at 11 and 18. I believe in Canada, you can go 80 meg wide at 11 now. That'll get you just over 700 megabits per second per carrier. So activating that second carrier gets you about 1.4 gigabits per second. If you're doing very small packet sizes, say 64 byte packet sizes, that's actually around 813 meg. So we have some very conservative marketing and engineering folks in Italy. I'd like to be able to say we can do 800 meg, but we recognize that not all networks have a single packet size or traffic type. Ethernet networks certainly have a mix of traffic and traffic sizes on there. So they spec it at about 700 meg or just over 700 meg per carrier there. And then in the Etsy world, where we can open this up to 112 meg wide, it's just over a gig throughput per carrier there. Okay. On the interfaces, the ALFOplus2XG has a 10 gig port. It's a field pluggable SFP plus. It can be either single mode or multi-mode. There's also another SFP cage there for a 1 or 2.5 gig SFP. And then there are two copper ports that do 100/1000 base T, both with the ability to do PoE. You see there's some management and a 48 volt port connector on there. Down at the bottom, it's some BNC connectors for a future implementation of MIMO. Okay. One of the very interesting things about the ALFOplus2XG is our integrated branching unit. And this is unlike other radios that are on the market where you've got to add pieces to the exterior of the radio. Our branching unit actually goes mates in the radio itself. And this branching unit allows the two carriers to operate in different modes here. So you can kind of see without the branching unit installed, the ALFOplus2, there's the two separate RF ports. In the first model, what we can do is we can just extend those RF ports to what we call a dual waveguide. So you can, if you've got a legacy network, maybe you've got some older radios, you want to just upgrade the radios and keep the antennas, we can put the ALFOplus2 radio next to the antennas, run a couple of pieces of flex waveguide, and then operate in XPIC mode or operate in adjacent channel, adjacent polarity mode, ACAP mode, maybe channel 1 vertical, channel 1 horizontal, or maybe channel 1 vertical, channel 2 horizontal. For those greenfield deployments where maybe you have a new system you want to run, we can do the same thing, but now we can mount the radio directly to the back of the antenna without any flex waveguides or anything like that. We can use the integrated OMT branching unit and achieve the same operation. So again, channel 1 vertical, channel 1 horizontal, or channel 1 vertical, channel 2 horizontal. And that's the integrated mount. Finally, on the bottom, if you've got the licenses come back and you say, you can see that I've got 2 horizontal channels or 2 vertical channels, we can operate with a hybrid branching unit. Again, the radio mounts directly to the back of the antenna, and we can operate channel 1 vertical, channel 1 vertical, channel 2 vertical, or channel 1 and 2 on the horizontal plane. So again, very flexible, very, very easy to implement, very easy to integrate with the hybrid or the OMT. And those just integrate right directly to the back of an antenna. No additional losses needed here. Onto the power options. We power the radio through 48 volts. So this standard telco 48 volts from the rectifier battery system to the radio. For those of you who might want to use PoE, we can certainly operate through either an AC PoE, We've got the options for DC PoE, either rack mount or outdoor provided. But the really nice thing about the ALFOplus2 is that you can do them simultaneously. So you can operate them with both PoE and direct 48-volt feed. In the event that one of the power supplies fails, you still have that redundant feed to the radio. The other really interesting thing about the ALFOplus2 radio is that we do not ask you to back the transmitter power down when you're running at max power on a PoE system. There are some radios on the market that say, well, you've got to back the transmitter down by 3 dB if you're running PoE, and it's just because those radios consume way too much at those power levels for those PoEs to handle here. So we don't do that with the ALFOplus2. Same power output regardless of whether it's a PoE or direct DC feed. With our radios, as you saw, we have several different radios that we offer on the marketplace, but the really nice thing about that is that they all share this universal product architecture, and in essence, the SMOS SIAE Microelectronica operating system. So if you learn how to operate an ALFOplus2XG radio, and then say you want to install an 80HDX, or maybe you want to install the split mount radio at a future date. It's all the same look and feel on the web interface. It's all the same networking features, so you don't have to relearn a whole new platform. Really, it helps minimize the retraining, and it maximizes the skill sets of the installers or the engineers there. And it's all standard with those CI products there. AES link encryption. So for those of you who are, maybe you've got a government link that you're installing, or maybe you're installing it for a bank or some financial institution. Maybe you're worried about link security. We have the ability to encrypt the traffic as it goes over the link. So we have AES encryption. It can either be 128 or 256. And that's a software upgrade to the radios here. Let's kind of shift gears now and talk about some TCO savings relative to just a 1+0 system here. So on the left-hand side, we've got a scenario where you might need a couple hundred megabits between point A and point B. So you have the engineer run the calculations and say, okay, I can run. This is a fairly long path. I can run with a 4-foot antenna on one side and a 6-foot antenna on the other side. And that yields me the 4 nines and a 5 or 5 nines availability that we need for this link here. Using 1024 QAM, it gives me just as a couple hundred megabits in a 30 megahertz channel. Let's take a look at doing that with a dual carrier radio. So if I were to take a dual carrier radio like the ALFOplus2, same 30 megahertz channel bandwidth, but I'm going to run 130 megahertz vertical, 130 megahertz horizontal. I'm going to run an XPIC mode. I can actually do that going down in modulation from 1024 QAM to 64 QAM. Each one of those carriers give me about 130 meg, so I get a little bit more. I get about 260 meg throughput. But note the antenna size can change because of the back off in modulation here. So I've gone from a 4-foot on one end and a 6-foot on the other end to 2-foot antennas here. So essentially a gain of 40 dB and 44 dBi on the first example gives me 84 dB of antenna gain. I've gone down to only 69 dB of antenna gain on the other model. So where did that extra 15 dB come from? Well, it came from backing down the modulation from 1024 to 64 QAM, which gives me a 12 dB improvement on receiver sensitivity, as well as a 3 dB improvement on transmit power, because I don't have to back the transmit power down as much and keep in the linear phase of the amplifiers. So there's a 15 dB gain improvement there. Now you can imagine, okay, there's going to be a little bit more A little bit more maybe for a dual carrier radio for a single carrier radio, but that compensates for it by smaller antennas. I've got maybe one extra license to do, but what I wanted to show you here is some of the TCO advantages here relative to a 1+0 system. So certainly if I look at the upper left corner here, I've got the radios, and these are all list prices, by the way. Your prices will certainly vary. You know, I just want to make an apples to apples list price comparison. You know, you might have a single carrier radio, some upgrades, PoE injectors, a 4 and 6 foot antenna, totaling about $15K for the CapEx. You've got to transport those radios. You got to get them from MBSI out to your site. You got to transport the antennas. Antennas, certainly larger antennas, going to cost a little more to transport. If you're leasing space on a tower, we're assuming $100 per month per foot of antenna size, not including any cables on that. And then you've got some installation materials, and of course, here in the U.S., the license fee for this would be about $1,500. So you're looking at a 3-year TCO of just about $58K. Now, if we did that with a 2+0 system, we've got certainly more expensive on the initial outlay for the radios. Because you're using a dual carrier radio instead of a single carrier radio. But you see the radio transportation costs are negligible. They're about the same. You got much lower transportation costs for 2-foot antennas than a 4 and a 6 foot antenna. And you're not leasing as much space on a tower for that. So at the end of the day, your 3-year TCO for the 2+0 system that's going to give you just a little bit better capacity is actually better than the 3-year TCO for that 1+0 system, and saving of just over about $400 a month TCO. So it's kind of people sometimes think of CapEx and OPEX. I try to tie them together because there is going to be a life cycle when you install these radios, and certainly if you were to extend this out 5 to 7 years and you're still leasing space on the tower, you can see that curve is just going to steepen with the longer number of years that you go in leasing that space there. Okay. With the ALFOplus2, we have a number of customers that are also deploying these in what we call a 4+0 configuration. So we're taking 2 ALFOplus2 radios, marrying them or sandwiching a coupler in between them, and then running some flex waveguide to an antenna. And in that case, it actually doubles the capacity over the single path there. Here in the U.S. anyway, at 6 lower, we're allowed up to 60 meg wide channels. So with 4 60 meg channels, we just get over 2 gigabits throughput at 6 gigahertz, which is phenomenal to think about. Even 5-10 years ago, wouldn't be able to do that. And 6 upper with 30 meg channels, that capacity is just over a gig. The interesting thing here at 11 and 18 gigahertz, and 11 gigahertz in Canada with 80 meg wide channels, you're up at almost 3 gigabits per second for an 11 gig path. And at 23 gigahertz, so with a 50 meg channel, you're just about 1.8 gigabits per second. And again, these are all full duplex numbers. So if you want to do the aggregate thing, and fake it with the aggregate, they just double that. But anyways, it's interesting. We have a number of customers, including a tier 1 operator here in the U.S. That have implemented this throughout a lot of their sites, and enjoying the benefits of doubling the throughput here. Let's just kind of move into segue into what we call multi-band systems. I think some of you have heard the term multi-band. It's kind of made its headway here in the last year, 18 months. And really, what is a multi-band system? It's a radio that comprises 2 separate bands that allow you to either extend the lengths extend the ranges of E-band links, or improve the throughput of microwave links. Okay. What CI does with our multiband system here is we marry the ALFOplus2 that we just reviewed on the prior slides with our 10 gigabit E-band radio, our ADHDX, and allows us to augment the capacity of the E-band radio with the microwave system and extend those E-band distances going multi-miles. So typically with an E-band system, you're talking maybe 1, 2, maybe 3 miles at the most, even with the 2-foot antennas here. And that's just a function of the very high frequency and the path attenuation at 70/80 gigahertz. Customers who want to maybe extend that E-band range can do that, but they typically find that the link availability suffers the further out they go. So what we do is we marry an ALFOplus2 with the E-band radio to augment the capacity. In the event the E-band radio fades, the ALFOplus2 radio still maintains traffic. It's not a switchover. I use the very careful and use the word augment as opposed to failover, as we really don't do any failover because we're aggregating all of this at layer 1. So we're bringing simply just bringing a 10 gig pipe from the switcher, the router, the base station, up to the E-band radio, jumping over to the microwave radio. We've got 3 carriers going on. In this case here, we got the 10 gig E-band carrier and the 2 microwave carriers that are operating at the same time. And as the traffic, as the E-band link fades, traffic is still maintained over the microwave system here. So this is just a brief slide on the 10 gig E-band radio, our ALFOplus ADHDX. It does 10 gigabit full duplex. It's got two 10 gig ports, 2 1 gig ports on it. We do hitless ACM B. We add the B to the ACM because we can also change the bandwidth as well as the modulation on this radio. So we can go from, say, 2,000 meg wide down to a 500 meg wide channel, in addition to changing the modulation. So when we do that, we actually can gain 6 dB on receive sensitivity, 3 dB in the change from 2,000 to 1,000, another 3 dB in the change from 1,000 to 500 megs. So adding that 6 dB is really important at these millimeter wave frequencies when you're trying to combat rain fades here. The highest transmit power of an E-band radio on the market today, 20 dBm. This radio will do up to 256 QAM. I mentioned the channels here, all the way up to 2,000 meg wide and down as far as 62.5 meg wide. Some of the other E-band vendors only go down to 250. We can actually go down to 62.5 and shrink that channel bandwidth down even more, and the resultant improvement in receive sensitivity when we do that. And as with the ALFOplus2, we can power it over 48 volts and or PoE, or do it simultaneously. A lot of the same features that you saw on the ALFOplus2 are shared with the ALFOplus ADHDX, because remember, we share that same SMOS, SIAE microelectronica operating system, and the platform behind it here. So when you're operating in a multi-band environment, what we did is we modeled a path here on the West Coast. I'm actually based here in California. We modeled a link here on the West Coast. We had an 80 gigahertz path and an 18 gigahertz path, about 5 miles in distance, both using 2-foot antennas. And then as you run the link calculations with the 80 gig radio, as you see over the rain fade, what happens is the link will decrease in throughput. The rain fade comes in and says, hey, I'm only going to be able to operate at 2 gig. And see my availability for that. What happens is as that link budget, as the link continues to fade on the E-band radio, you see that in red. On the microwave radio, the throughput still is maintained, so we can infill capacity with the microwave radio. So for example, at 99.5%, availability. We're operating about 8.2 gigs using the E-band radio, but we're still at 9.6 gig with total throughput because the microwave radio is augmenting that traffic. And then as the rain continues over the path, or the rain cell intensifies, the E-band radio will fade. It's just physics. And then the microwave radio will still maintain. In this case here, we can still maintain 5 nines availability with almost a gig throughput over this path here. So this is an ideal way for service providers and operators to provide, say, 10 gig best effort throughputs, and then being able to back that up with an SLA of say 1 gig, where you've got customers who have really high demands for those high capacity SLAs here. Okay. I wanted to switch gears here and just talk briefly about our ALFOplus radio. This is a very cost-effective, economical way for you to get up to about 500 megabits between point A and point B. This is a radio that's been on the market now, excuse me, for a number of years. Have been tried and true for probably, I want to say, the last, excuse me, 7 or 8 years. And it was the first radio on the market as we bring these innovations to market. First at 1024 QAM. We've got a number of mobile operators, WISPs. Here in the US, we find this radio being used by a lot of WISPs who are just interested in a couple hundred megabits between point A and point B for their customers. There's no need to go off and spend the money on a dual carrier system when they just are selling a couple hundred meg, and this radio here perfectly fits the bill. It's a very nice balance between economy and throughput there. Again, this tier 1 mobile pedigree, so a lot of hardened construction. It's carrier grade. It's got a built-in 2-port switch. And then some more of the features here of the radio. Now we're getting close to the top of the hour, so I'm going to kind of speed it up. It's 100 megabits out of the box with the ability to go up to 500 meg. We're doing it today here at 11, 18, and then 23 gigahertz. Again, you can see the images over on the right-hand side, direct mount to the back of the antenna. This is an MEF 9 and 14 compliant radio. Been tested with the forum group, and this also has a feature in it that we have worked with Cisco on to what we do call microwave adaptive bandwidth. So there are a number of Cisco cell site routers that are in use, not just for the cellular companies, but we're finding that WISPs are using these too. We've worked with Cisco to enable a feature within the radio to talk to the cell site routers. In very simple terms, if there's a rain fade that happens, we can actually be proactive in telling the router that you're going to get reduced throughput, and if you've got to change your routing tables, we can do that. In fact, if you went on to a Cisco's website and did a search for SIAE, there's a white paper that we co-authored on it there. So we've done some integration with Cisco on that too. Something we just released about 1.5 years ago, it's available both here in the US and in Canada, is the ALFOplus2XG-4+0. This operates in the unlicensed ISM band. This is that little chunk of spectrum between 2405 and 2425. So there's a little 200 meg swatch of spectrum that's unlicensed in both countries. It's homologated under Part 15 here in the US and RSS 210 in Canada. There are 2 options for this radio. There's what we call an electrical optical interface. So you see the 2 ports on the bottom of the radio. One is an electrical RJ45. The other is an optical port where we can plug an SFP into. Or there's an option for just 2 electrical if you're running. Maybe you just want to run 2 Cat5s to the radio. Can do that too. The antennas for the ALFOplus2XG-4 are limited in 12-inch antennas, and that's just due to the EIRP regulations in this band from both FCC and Industry Canada. So we have 2 flavors of 12-inch antennas that the radios were homologated with. Again, direct to the back of the antenna. It shares the same PoE and DC feeds we talked about earlier. Hardened. So unlike some of the other 24 gig radios on the market that may be plastic housings, these are our hardened carrier grade microwave radio systems. And then the other thing about this radio that's different from, say, a B24 or an AF24 is that this is an FDD radio. So this is just like any other licensed microwave radio. You can plan it just like any other licensed microwave radio. This is one go and one return channel. From a latency perspective and from a predictability perspective, you can predict these just as you can do predict with a traditional 6 to 38 gig licensed microwave link. Okay. So let me just kind of wrap it up, and then I guess Cody will turn it over some questions. So just kind of went through the company, went through the ALFOplus2 product in detail. Again, if you got questions on some of the products that you may not have covered, say the split mount, or maybe want some more information on the E-band products, certainly drop us a line. We'd be happy to get you that information here, but just kind of want to wrap it up here with why SIAE Microelectronica here. So from a company perspective, been around 69 years, very mature company, very well established. We're financially strong. Not looking for an investment. We're privately held, so we answer the brothers like to say we answer to customers, not shareholders. So we can we've got the flexibility to put a lot of money back into R&D as opposed to paying dividends. We have an excellent list of tier 1 carrier references worldwide. You saw on the slides prior, companies like Vodafone, Telefonica, MTS, SFR. Being able to provide radios into that market requires a very solid product, which we do. We own our own factory, we build our own products, we control the quality, we control the process, and on average about 11,000 radios a month is what we can do out of our Milan factory. And then for customers here in North America, we have we're one of 26 subsidiaries, so we can react quickly to customers here in the U.S. and Canada, provide that support for you from the local time zone, as opposed to supporting from outside the U.S. here. On the product strength side, I hope you saw that we have a complete portfolio of licensed microwave radios. Here in North America, we sell them from 6 to 23 gigahertz and millimeter wave radios too, the 80 gigahertz E-band radios. Talked about the tier 1 carrier grade proven quality and hardened design. We have systems from 100 megabits all the way up to 20 gig. The way we reach 20 gig is we can just marry two 10 gig radios, E-band radios. We had talked about the common OS system with the SIAE Microelectronica OS. So if you learn one radio, you can operate all of them. And we continue to innovate and bring features to the market, such as the radios with 4096 QAM RF multicore, multiband aggregation, etc. So this is some of the things to think about when you're looking for a microwave radio vendor here. So I think, Cody, with that, I'm going to turn it over. We get some questions here. I think the first one here is the PoE 8023AF or 8023F. It's neither. It's these radios here consume more power than, say, an AF device. The ALFOplus2 radio itself has got about 75 watt power consumption. The PoEs that we provide for those radios are rated at 95 to 100 watts, and we do that on purpose because we want to make sure that we also have the ability to have the PoE handle the inrush current when you first turn the radio on. So we typically oversize the PoEs about 20 to 25% just to make sure that those PoEs work with the radio. They work at the lower input voltage, as well as handle the inrush current. And that's one of the reasons why our radios don't have to back off the transmit power when we use PoE. Okay.
All right. Thank you, Joe. I think that's all for questions. If anybody has anything last minute, feel free to pop it in that chat window now. So let's get to our skill testing question. So I'll just give everybody a moment to get that chat window opened up again at the bottom of the Zoom platform. And we will ask that here in just a couple seconds. Just give everybody an opportunity to get that up and open and ready. And just a reminder, you do have to be in Canada to be eligible for this. So, okay, here we go. So what is the difference between the ALFOplus and the ALFOplus2XG radios? And what is the bandwidth they can each push through? I'll just wait for some feedback to come in.
Good deal. Again, while we're waiting for the feedback to come in, Cody, let me just, I'm just going to close here by saying thank you to you and Nicole and the team at MBSI for putting this on and for allowing us the opportunity to reach out to the folks on the webinar today. We really appreciate the work that you're doing, and we appreciate everybody joining the webinar today. So thank you very much on behalf of all of us at SIAE Microelectronica, and we look forward to working with you on your microwave projects.
Thank you, Joe. Just hold up a moment, folks. We're just waiting to tally our results here. All right, we have our winner, Michael. So we will be in touch with you to get you that gift card. So thank you very much, everybody, for attending. Again, thank you so much, Joe. A lot of great information. Really appreciate you taking the time. And again, to all of our attendees, thank you so much for attending. We know your time is probably your most valuable asset, so we always appreciate it. If you have any other questions, comments, you want to see some budgetary numbers, some designs on the CI product line, feel free to reach out to your sales rep at MBSI WAV or the sales email there that you see up on the screen. Again, we're going to be hosting some more future webinars here in 2021, so we'll make sure to keep everybody posted on those as it comes along. And thank you all, and enjoy the rest of your week. Thanks, Joe.
All right, thanks everyone.